All right, we're going to start chapter 6. I think you guys are going to like this stuff. So there's applications of integration, and it kind of gets really cool with some of this stuff. This first lesson is very easy, and even if I didn't teach you, you could probably figure it out without me. So it's the area of a region between two curves. And this, for the most part, is kind of obvious. So let me write a formula. So if we want to get the area bounded by um, f of x, that would be this area right here, right? So if we wanted to get that area, we would use the formula. Let's see. It's going to be equal to the integral from a to b of f of x dx. And let's say our goal is to get this area. Well, we can't get that area, but we can get this area of f of x, and we can get this area of g of x, which would be under this curve. And I think it's pretty obvious if we subtract the two areas, we will be left with this area, because this is the area, this is what we're actually trying to figure out. This is our goal. So anyhow, the area of the whole thing in orange was the area of a to b of f of x dx. The area of the green is going to be from a to b of g of x dx. So the area of the entire, this area that's between the two curves would be the area from a to b of f of x dx minus from a to b g of x dx. And, you can write it like that, or we could actually combine it from a to b of f of x minus g of x dx. And like I said, I think that's pretty obvious. I think you would have been able to figure that out. So all you have to do is if you can find the integral of one and you can find the integral of the other, you subtract them. It's pretty straightforward, and hopefully you all realize that as well. I'm going to show you a few quick examples. I'd like to do 4 of them. Let's see how that goes. So the first example, pretty standard, but let's find the area between the graphs of x squared plus 2 and, well, we're going to graph it. Let me show you. So find the area between bounded by y equals x squared plus 2, y equals negative x equals 0, and x equals 1. So we have to kind of sketch that out to see what's happening. So let's do that. All right, let's see. So, x squared plus 2, that's a parabola going right like this. Y equals negative x is a straight line going like this. X equals 0 is a vertical line right here. And x equals 1 is a vertical line right here. So we want to get this area. And so the vertical lines are just going to serve as our a and b values. So really what we have here is the integral from 0 to 1 of the top curve, which is going to be x squared plus 2, minus the bottom curve, which is negative x. And once we simplify that, this one is really not too difficult. So from 0 to 1 of x squared plus x plus 2. And when we integrate that, we're going to add 1 to the exponent and reciprocals of that. So 1/3 x cubed, add 1 and reciprocal it, 1/2 x squared, and 2x. And that's from 0 to 1. And now all we do are plug in our values. So you see that this is definitely not a difficult concept. If you can integrate and do the area between one curve, then getting the area between two curves is not too bad. So anyhow, plug in 1. We're going to get 1/3 plus 1/2 plus 2 minus 0 plus 0 plus 0. Obviously that just goes away. 1/3 and 1/2 is 5/6 plus 2 is 12/6. So 17/6 should be our answer right there, which is 2 1/6. But we're going to leave it like this. Okay, so hopefully you follow along with all that. The steps there are definitely not too extreme. I think you can all handle that.